In this video today, we are decoding the discriminant, or in other words, we can say finding out the nature of the roots of the given quadratic equation and learning how to look inside a quadratic equation to predict its answer before even we solve it. When we look at the standard form of quadratic equation, that is your ax squared plus bx plus c is equal to 0, we use the quadratic formula to find our answers. But notice the specific part sitting right underneath the square root symbol. This little expression b squared minus 4ac is our discriminant. Denoted by the capital letter D, it's called as a discriminant as it tells the difference between the types of the roots we will get. Depending on what number we get for D, there are three rules. If D is greater than 0, we get two distinct real roots. If D is equal to 0, we get two equal roots. And if D is less than 0, we get no real roots at all. Let's look at three step-by-step examples to see how this works algebraically and graphically. Let's consider the case 1, taking the quadratic equation 2x squared plus x minus 1 is equal to 0. When we compare this with the standard form for quadratic equation, we get the coefficients a, b, and c. By placing the value of a, b, and c in the given the value of d, we solve it and get the discriminant as 9. Since 9 is greater than 0, our rule says we have two distinct real roots. If we verify this using the full quadratic formula, we get the value of x, that is your 0.5 and minus 1. Let's look up. On the right, notice the parabola which cuts the right through the axis exactly at those two verified points. This tells us that we are getting two unique roots when the value of d is greater than 0. Now we consider the second example, the case 2, where x squared plus 4x plus 4 is equal to 0. By comparing this with the standard form of a quadratic equation, we get the coefficients as a, b, and c, 1, 4, and 4 respectively. Here, when we place this value in D, we get exactly as 0. A discriminant 0 means we have two equal real roots or one unique repeated roots. Verify this with our formula leaves us with x is equal to minus 2. And if you see the graph on the right, here the parabola touches the x-axis at exactly at minus 2 point before turning back around. Now we have got the third example, that here in this case we will be getting the value of d as minus 3, and we know finding out the square root of minus 3 will not give us the real value, so we will have no real roots. And graphically, you see on the graph on the graph on the right, here the parabola does not touches the x-axis. It hovers around above the x-axis and turn around. Now let's see the recap of all the three nature of the roots, and here we are able to see that when we have d as greater than 0, we have got the two unique roots, and when d is equal to 0, we have got simple one root repeated roots, or we have the two equal roots, and when d is less than 0, we don't have any real roots. I hope you people have understood the concept to find out the nature of the roots, and with the help of this we can assess what kind of the answer we will be getting if we know the nature of